First question, page 302, ABC. 1, 10, 7, 10. That's the answer for 1A. Then I just asked you to jump down and plug it in. So negative b plus or minus the square root of b squared, 49. Negative 4 times a times c is going to be negative 40. 49 minus 40 is 9. So negative 7 plus 3 divided by 2, because the square root of 9 is 3, which would be negative 2. And negative 7 minus 3 divided by 2, which is negative 5. That one looks familiar. I wonder if we didn't already do that problem. Question number 2. Can you use the quadratic equation for this one? Yeah. The only kicker is you don't have any x's, which is fine. That just means b is 0. That should make it easier for you. So can you still use it? Yes. How do you know? Well, you still have an a, you have a b, and you have a c. Can you solve it using the square roots? So if I add 39, and I just take the square root of both sides, and I get the square root of 39. I'll just leave it like that. So yes, you can. Question number 3, again, I asked you to solve this one. I think Georgia was supposed to give us an equation and failed.
I tried to find one that would be
A, B, C. So 3 plus or minus square root of b squared is 9. Negative 4 times a times c over 2a. 9. This multiplied together is 32. 9 plus 32. 41. Over 4, we'll leave it just like that. Come on, Georgia. You gotta come up with a better one than that.
I'll be ready for this.
Question number 4. Can you find a mistake? Well, he completed a square. So 8 divided by 2 is 4. 4 squared is 16. So he said, oh, there's already an 11 here. So I'll just add 5. The problem is he didn't add 5 over here. So if you're going to do that, instead of this 4, it would have to be 9. Then you take the square root of both sides, and you get 3 and negative 3. So your answers are negative 1 and negative 7.
But I feel like, wouldn't you just subtract 11 to get those numbers?
Yes, you could have, but that's not what he did.
I feel like it's the easier way.
That's fine, you're still going to get this answer then.
That was the. Oh.
Question number 5. Solve by using the quadratic equation. You could also factor. This one would have factored as 2x minus 5 and x plus 1. If you chose the factor, if not, and you plug in a, b, and c, it would be the same. But your answers should be 5 over 2 and negative 1. This question, I'm going to bring that 21 over. Factors of 21 that differ by negative 4. I would have factored that one again. I think that's easier. Otherwise, A, B, C,
I'm not good.
same answers.
Yeah, I mean, I'd rather just do the quadratic.
Yep.
How would you
That's fine.
complete the square? Or, yeah,
I don't think I want to show you that
Well, I have a question.
for fear of confusing you more. You divide by 2 and square it, and then you add it to both sides. Yes?
So you can always do the quadratic formula, but you can't always factor?
Correct.
Can you always do the find the perfect square?
Complete the square?
Or, yeah.
Yes.
I mean, technically you could always factor it, just take forever.
And it might be messy numbers.
Yeah.
I mean, if you're talking a square root answer, that would be a nightmare to factor. Same thing with this one. Again, A, B, C. Negative 4, negative 1, C. I like to write it in that order. Your answers you should come up with are negative 1 and 3/4. Question number 6, find the solutions. without graphing. So again, I would write it in the correct order. It's going to be 6 subtracted from 4. That'd be a -2 if I'm going to set it equal to 0. Again, we've done so many of these, I'll just show you A, B, and C. Your answers should be 1/2 and 1/4 for that one. What does the solution say about the tennis ball? That is the time when the ball is 6 feet in the air. Because you set it equal to 6 at the beginning. That is when the ball is 6 feet in the air. X-intercepts should be 0 and 6. That's what would make those zeros there. So 0 and 6 for sure go through those dots. What is the x-coordinate of the vertex? So what is between 0 and 6? 3. So it's going to be here somewhere. How do you know it's in the middle of 0 and 6? Between 0 and 6. What is the y-coordinate? I'm going to plug in 3 then. So 2 times 3 times 6 minus 3. Plugging it back into the equation. 2 times 3 is 6. 6 minus 3 is 3. So the y-coordinate is 18.
So do you have
They didn't
to,
make room for that, which was dumb.
2, 4, 6, 8, 10, 12, 14. So yeah, it's going to be like right here. So it is 318.
so if I take,
All right, that is it. Go ahead and do the warm-up.